Okay, pardon me. I'm coughing and kind of have cold. Um, so in the previous video, I showed you how to do this on Excel, and the final option was um, cumulative, or the cumulative option I set as false because we learned cumulative probability in chapter 3 when we learned median. So now we are looking for probability with equality, not inequality. So we will set it as false. But later, in a later question, we are going to use this option as true. So you are going to see the difference, why, whether we have to use it as true or false. Okay, the next question. A banker reviews 40 loan applications a day. The acceptance rate of a loan application is 25%. Suppose that the acceptance decision is independent across applications. What is the mean and the variance of the number of accepted applications by the banker on a day? Pretty simple. We know the formula, and it only depends on the parameters n and p. So we just define the binomial distribution as y, and then in this case, reviewing one application is one experiment, right? Acceptance happens with 25%. So one application is one experiment. Probability of success is 25%, and there are 40 applications reviewed in a day. So n is 40 and p is 25%. Apply these two numbers to apply the formulas to these numbers, then plug those numbers in. You get 40 times 25%, which will be 10, right? And the variance is n times probability of success times probability of failure. So 40 times 25 times 0.75. So simple formula, you can calculate that, right? Okay, that is it. Next question. Suppose that a large shipment of components contains 5% defectives. The following two acceptance rules are being considered for determining whether to take delivery of a shipment of the components. So you are comparing two different rules. Rule 1. A random sample of 3 components is inspected, and the shipment is accepted only if none of them is defective. Rule 2. A random sample of 10 components is checked, and the shipment is accepted only if no more than one of them is defective. So, and then which of these acceptance rules has the smaller probability of accepting a shipment? So it's interesting. Rule 1 checks only 3 components, but does not allow any defective parts. But in rule 2, it inspects more, like 10, but it allows 1 defective part. Then which is more strict, or which is more strict? Basically, that is the smaller probability of accepting a shipment. We can apply the binomial distribution again here. So I will call the first rule as y. Y is the number of defective components when randomly chosen 3 components are inspected. That is rule 1. And z is the number of defective components when randomly chosen 10 components are inspected. That is rule 2. And then you know they are binomial distributions with different n. The probability of defect are the same, right? 5%, they are basically the same shipment, but the number of inspections are different. And then finally, we are going to compare the acceptance probabilities, which is in rule 1, y should be 0, right? In rule 2, z, the number of defects can be 1 or 0. Then it's accepted. Which is smaller? We are going to calculate the binomial distribution probability. It is doable, like numbers are not that complicated. So for rule 1, you are going to calculate this. Out of 3, there should be nothing. You are choosing nothing. So basically, this is only one scenario. None is defective. So then, the probability of non-defect happens 3 times. So just calculate that probability. That is simple. So just simply, there is only one case. Everything should be fine. But in rule 2, you have to think about two cases where there is no defect plus where there is only one defect. And for 0, for the probability z equals to 0, 10 chooses 0, which is also again 1 because everything should be fine, and 95% happens 10 times. Fine, everything is fine, so 95% multiplied 10 times. Next, the next term, for the probability z equals to 1, for only one component to be defective, you have to think about 10 chooses 1. Like you have to think about which one out of 10 is defective. So there is a combination rule times 9 of them are fine, but 1 is defective. So 5% is multiplied once, and 95% are multiplied 9 times for fine components. And then you have to calculate these things. And I don't know the answer. Do the math, do the algebra, and find which is smaller. Right? That is easy. Next question. A state senator believes that 70% of all senators on the finance committee will strongly support a tax proposal she wishes to advance. Suppose that her belief is correct and that 5 senators are approached at random. What is the probability that 3 or fewer senators will strongly support the proposal, right? So it is another binomial distribution example. So I'm going to define Y as the number of senators who strongly support the proposal among when 5 senators are randomly chosen. You ask 5 random senators, and Y is the number of senators who strongly support the proposal. And then in this case, the parameters are 5. So when you randomly choose a senator and ask about her opinion, that is one experiment, whether she supports or not, right? So one senator is one experiment, and the probability of support is 70%. So P is 70%. So in this case, we are wondering the probability that 3 or fewer senators will strongly support. So we are calculating probability Y is 3 or fewer, smaller than or equal to 3. Okay, so this includes 0, 1, 2, 3. So you have to calculate 4 probabilities, but a better approach would be calculating the other side, 5 and 4. Okay, so if you want to calculate 5 and 4 probabilities for 5 and 4, you can just apply the formula. 5 chooses 5, and 70% happened 5 times. Okay, that is probability of 5. And 5 chooses 4, and then 70% happened 4 times, and 30% happened once. So you can calculate this probability. But it is cumbersome, so we are going to use Excel. again, the formula you are going to use is binomial distribution, right? BINOM dot DIST. And here we are going to enter number of success is 3. We are interested in 3 or fewer, and out of 5 and 70%. Finally, I'm going to set the cumulative option as true. Then what it calculates is, it calculates probability y is smaller than equal to 3. So it calculates probability smaller than or equal to 3. So here, this is exactly the cumulative probability we defined in chapter 3. So when you set true, you are going to get this. So you don't need to do these complicated things. But when you set the option as false, it will calculate the probability of equality, right? So that's the difference between cumulative probability or just a probability with equality. Okay. Final question, which is a similar question. An official from the Securities Commission estimates that 70% of all online bankers have profited from the use of insider information, which is inappropriate. Assume that 15 online bankers are selected at random from the Commission's registry. Find the probability that 12 or fewer online bankers have profited from insider information. I inspired this question from the coin traders, criminals. Of course, it is just made up numbers. I believe all the bankers, online bankers, are doing well and doing what is right. Okay. Anyhow, back to the question. Why I'm going to define Y as the number of online bankers who use the insider information. Okay, and we are going to calculate this probability that Y is 12 or fewer. And if you use the formula, you are going to calculate these probabilities and subtract from 100%. But it'll be really, really difficult. So just go to Excel. I will show you how to do this. Like, say, let me check again. The 15 and 70%, those parameters, don't forget. So I set the cumulative probability as true again because it is inequality. So then the answer is 87.317%. So again, this is in the form of a cumulative probability. So you can use binom DIST formula with the last option as true. Okay. Okay. Thank you for watching. This was quiz 5, and I hope you stay healthy. And see you next week.